Welcome and thank you for joining us today for Readying Enterprise Networks for Artificial Intelligence. My name is Raleigh Gould and I'll be moderating today's event. Our featured speaker is Shamus McGillicuddy, VP of Research covering Network Infrastructure and Operations at EMA. Shamus has nearly 2 decades of experience in the IT industry. His research focuses on all aspects of managing enterprise networks, including network automation, AA Ops-driven network operations, multi-cloud networking, and WAN transformation. And before I hand things over to Shamus, I wanted today's audience to know that Shamus will be wrapping up today's presentation by taking your questions. Feel free to log them anytime by using the Q&A functionality. Also, today's event is being recorded and you will receive a follow-up email with the on-demand playback as well as a link to learn more about the report. So I hope you will check that email out. And now I'd like to go ahead and turn things over to our featured speaker, Shamus McGillicuddy. Shamus?
Thanks, Raleigh, and thank you everyone for joining me today for this webinar. So the title of this webinar and the title of the research it is based upon is Readying Enterprise Networks for Artificial Intelligence. So the goal was to get a sense of what early adopters of AI who are developing, training, operating AI applications that transform their businesses in some way. Like, what are they doing to ready their networks to support the types of traffic that such applications generate? Because big topic conversation has been those applications. AI has very strict requirements for latency and things like that, and can create a lot of congestion. There are a lot of challenges around it from a performance and availability perspective, a bandwidth requirements perspective, security perspective. It impacts, observability requirements because you need to be able to manage all that stuff proactively. So we surveyed some early adopters on this topic, and it was made financially possible by the sponsors of the research, which are displayed here: Ariaka, Blue Cat, and Versa. So this is independent research. They get to talk about what they hope to learn, and then I go off and I do the research without any real editorial, well, zero editorial input from them, but they benefit from it in various ways. They get to use the data in their own marketing programs, and it gives them a lot of insight into what their customers are going to need and what they're doing. So thank you to these vendors for helping me make this research possible. In terms of research methodology, I mentioned we were surveying two organizations that are already engaged with AI, early adopters, you might say. We surveyed 269 IT professionals involved in preparing their networks for AI applications and traffic. I was shooting for 250, we overshot, so sorry for the odd number. But these people were subject matter experts, middle management in IT, and IT executives. So a mix of people up and down the spectrum, all directly engaged with what their organizations are doing around AI and preparing their networks for AI. And all of them had to have a corporate AI strategy that was already in progress. 74% of them had at least some AI applications in production. The rest were planning, developing AI applications, things like that. But as you can see, nearly 3/4 of them actually had some AI applications in production. And then this is a demographic slide. You see almost half of them were at executive level, and a third were director level, and then the rest were sort of in the trenches, so to speak. And then it's a mix of mid-sized enterprise, enterprise and large enterprise. Given there's so many CTOs, CIOs, and directors, like most of these people are in an IT executive suite, but we also have a lot of security people, IT architecture, network infrastructure and operations, cloud operations as well. And then, there are 4 big verticals represented. Well, I guess 5 that are significantly represented. Financial sector, heavy industrial manufacturing, retail, wholesale distribution, consumer goods manufacturing, and healthcare, pharmaceutical, biotech. And professional services not related to IT was pretty prominent as well. There are about 6 or 7 other verticals that we caught in the 3 to 5% range as well. In terms of what they're doing around general AI strategy and thinking around their network. We're going to start just at a high level, and then we'll dive into um, a closer look at what they're doing in the data center networks, what they're doing in their wide area networks around AI preparation, and then we'll look at network observability and security as well. So uh, we were looking at we started off by asking them a few questions around like AI strategy. First off, 42% of them said that they had formed an AI center of excellence to lead AI strategy and AI implementation. And incidentally, people that had done that were generally more successful or feeling more successful and more advanced in their implementation of AI. They were moving along. They were moving more quickly, or they had more experience and had um, with AI in general, and were just doing it for a longer period of time, and thus were further along the adoption life cycle. We also asked them, like, what kinds of technologies do you think you'll have in production by the end of the year? And you see, most of them will have been using proprietary large language models by the end of this year, and more than half will have been using some kind of machine learning in their AI projects. Um, Other things like open source large language models, agentic AI, less further along by the end of the year, and retrieval augmented generation. Not a lot of adoption there by the end of the year, although that's probably the least hyped um, of these topics. And maybe they just aren't really aware of RAG that much, and maybe they are doing it but aren't aware because they are an executive level. But yeah, RAG is the least active of these AI technologies we surveyed them about. We also asked them to tell us where they think their AI workloads are going to live. So here you see answers to questions about where AI workloads will live by the end of 2028. On the left, it's training workloads. And on the right, it's inference workloads. Pretty similar patterns, little variation from training to inference. But the general pattern you see here is workloads concentrated a bit in traditional public cloud, like the hyperscalers. Significant presence in private data centers, whether it's on-prem or colo, and then an expectation that they are going to be using the GPU as a service specialists that are emerging on the market right now. GPU cloud specialists, and then a lot of emerging interest around deploying AI workloads at the corporate edge and edge compute environments as well, which allows them to have workloads residing closer to edge data in the enterprise, which helps them combat latency issues and things like that. And so my big takeaway here is that the typical enterprise is going to need to make sure that its data center network is ready to support workloads, AI workloads, but also given how distributed this is, across public and private infrastructure from the edge, across different types of clouds, the wide area network is also going to need to be AI ready as well. We also asked them what kinds of challenges they're seeing so far. On the left, we asked them just general business concerns around whether their network is capable of supporting AI, like what network-related business concerns you have in your AI strategy. And no surprise, number one, security risk. People are always worried about security risk. No matter what topic we're asking them about, they're always kind of worried about how a new technology, a new initiative is going to expose them to security risk. And it is the number one issue here as well. And then secondarily, you see three things that pop to the top of a list of, I think, maybe like 9 or 10 multiple choice options. Cost or budget, like it's not cheap to make your network AI ready. You might need to invest in a lot of new switches. You might need to upgrade your wide area network or switch vendors, or you may need to do some things around not just your your SD-WAN or SASE overlay, but you might need to make some changes to your underlay around like what kind of connectivity your AI traffic's going over. Uh, Also, secondary business concerns, rapid technology evolution. People just feel like the new developments in AI happen so rapidly. They're just, it seems like 3 years ago people were talking about machine learning. 2 years ago they were talking about large language models and generative AI. This year they're talking about agentic AI. What are they going to be talking about in 6 months? Who knows? Like I've got my strategy in place for the AI that we're talking about yesterday and today, maybe. But what about in 6 months or 12? I don't know. It's hard to keep up. I guess the best thing we can do is just build the best possible network we can based on what we know now and hope that it's ready in the future. And then skills gaps, another issue. Just hey, we're adopting new protocols. We're working with new vendors that we haven't worked with before. Do our network teams know how to support this? On the right, we got some specific issues into the sort of like the technical challenges around data center networking and when it comes to supporting AI. So in the data center, they're worried about the integration between whatever they're building to support AI traffic to integrate that with legacy networks effectively. They seem to be concerned about that. Obviously, they're also just hyper aware of the fact that there's going to be a lot of bandwidth demand from AI in their data centers, and you know building enough capacity to support that. Given the fact that budget is obviously a concern on the left, there's going to be sort of a trade-off there, or there's going to be a sort of like a push-pull factor, like, oh, we need more bandwidth, but do we have enough money? Coordinating traffic flows of synchronized AI workloads. A lot of these big models in AI are coordinating how workloads process data in parallel across multiple hosts. And that's going to require some coordinating of traffic to make sure that that those synchronized AI workloads aren't disrupted by things like congestion and packet drops and latency and things like that. And speaking of which, latency, that's also that's the number 4 challenge in the data center, is like, oh, we got to keep latency down in the data center. Latency is a bigger issue, and when it comes to the WAN, from what we're seeing here, it's the number 2 issue: latency between workloads and data at the WAN edge. Our AI workloads in our data centers and our clouds need to reach out to the WAN edge for training data, or to make inferences from our corporate data. There's a lot of latency involved there, and we'll get into that in a second. We've kind of already referenced the fact that there's a lot of edge compute expectations coming up by the end of 2028. But the number 1 challenge in the WAN is just complexity of workload distribution across sites, which also points to the previous slide that showed that AI workloads are going to be very distributed across different parts of your network. And then the big secondary challenges here: complexity of traffic prioritization. Like, how do we make sure that we are prioritizing AI traffic, and it's good AI traffic we want? And then network congestion, because bandwidth demand in data center, you can install 800 gigabit Ethernet switches and get a lot of bandwidth in your data center, but when it comes to the wide area network, your providers only have so much bandwidth they can offer you at the edge of your network. And that's going to be an issue that you're going to have to take steps to mitigate the amount of traffic that's hitting your network from AI workloads. Okay, so network infrastructure preparation. Data center first. Bear in mind that these are early adopters of AI. 74% of them have AI applications in production, and yet only 49% said that their data center networks are completely ready for AI traffic. The other half saw some gaps, even though many of them already have AI applications in production. We asked them what kinds of infrastructure investments they're doing. The big one, 3 out of 4 of them said, oh, we're installing high-speed Ethernet switching in our data centers, like 800 gigabit Ethernet. It's definitely on our adoption plans. 56% said that they're adopting hyper-converged infrastructure. So most of the big IT vendors have been rolling out updated or new HCI, hybrid converged infrastructure stacks solutions, bundling, networking, compute, especially compute specialized for AI workloads and storage as well, and orchestration and maybe security. All the big vendors have been rolling that out, usually in some sort of partnership or alliance with NVIDIA around their GPUs. And so the majority of the people in this survey are planning to adopt that if they haven't already. And then you see 45% are adopting SmartNICs and DPUs. That means either they're installing servers that have those on them to offload and compute intensive networking network processing, or there's an emerging generation of network switches that have DPUs in them as well to offload layer 4 through 7 processing, like so that you can run firewalls and load balancers or other network services in your switching infrastructure, so that you can um, reduce the amount of latency associated with, like, forwarding traffic to a firewall somewhere. You can just have the firewall installed on the switch. So that's something they're doing to combat latency in their data center networks and reduce overhead on servers and stuff. And then on the bottom, you see like what kinds of network protocols they say they're adopting. Hey, Ethernet seems obvious. Yeah, that 67% said their data center networks will be using Ethernet, as opposed to some of the things you see on the right, like NVMe over fabrics or InfiniBand. And then 64% said they're using RoCE or RDMA over converged Ethernet, which is a standard that enhances Ethernet so that it has some congestion control and latency mitigation capabilities and things like that. And and in the future, we would, in future versions of this research, would probably ask them about like Ultra Ethernet, which is an emerging standard as well, that sort of enhances Ethernet to support things like AI. But so that gives you a sense that Ethernet is definitely dominant in these data centers, but there is a lot of interest in InfiniBand and NVMe over fabrics for sort of an alternative approach to handling AI traffic in their data centers. Then zooming in on the wide area, only 48% of these early adopters of AI say that their WAN is ready for AI traffic, completely ready for AI traffic. So they see some gaps right now as well. And we asked them, what kinds of solutions support your transition to AI ready WAN? And you see, number one response was, I need high performance cloud interconnects. So I'm connecting my data center to the public cloud, or maybe I'm connecting one cloud to another, or GPU provider to a hyperscaler or something like that. I need high performance interconnects between them. And then 56% said they were adopting private dedicated AI backbone networks, an emerging class of service providers that offer backbone infrastructure that they can peer to move a large amount of AI related traffic very quickly with low latency and high bandwidth. And then 53% said their WAN overlay solutions were very important to their AI networking strategy, meaning software-defined WAN and secure access service edge. So those are the top three responses to a question about essential solutions. And then we also asked them, what kinds of WAN optimization or acceleration techniques do you need to apply to AI traffic? These are the top four responses, and they're all AI aware something. So number one, they really want AI aware bandwidth efficiency techniques like data dedupe or compression that is smart about AI data. Can it effectively deduplicate packets associated with these particular AI applications? And then nearly as many said they want AI aware data transmission acceleration, like, let's have a WAN optimization solution or an SD-WAN solution that is smart about optimizing how AI protocols move across the network. And then nearly half said we want AI aware WAN remediation, like, so something like a forward error correction type of capability that is smart about AI packets that are dropped and things like that. And AI where traffic prioritization or shaping. So, I need like to be able to set a quality of service setting for these specific AI applications to make sure that they are always prioritized. Um, and then also we saw in this research, 64% of people surveyed said that they're trying to reduce WAN latency by deploying AI workloads at edge computing locations so that those workloads are closer to the data that they have to process, enterprise data they have to process. All right, so let's talk about how these people are securing AI investments. First, we asked them about their security concerns. These are the top four things they're worried about. The big one is they're worried about data privacy and compliance risks. They're doing all this training of AI with their data and maybe customer data, maybe third-party data, um, and they want to make sure that that data is not exposed uh, to malicious actors, that is not leaked, that they are in compliance with all regulatory regimes around things like healthcare privacy, financial data, personally identifiable data being protected, data sovereignty. Like they need to make sure that whatever they're doing with this data as it's crossing their network, that it is locked down properly. And then secondarily, they're very worried about vulnerabilities in sort of like the supply chain with things like APIs to and third-party integrations. If they're using a proprietary large language model, for instance, we want to make sure that integrations of their stuff with that third-party LLM is locked down and not being hacked in some way. They're also worried about targeted attacks against their AI models. That is something that I'm seeing a lot of chatter about right now. And in social media, for instance, and it's clearly of top of mind here, or secondarily, the thing they think they worry about after data privacy and compliance. And then just data leakage, just generally is another concern, kind of related to things like data privacy, but not necessarily completely overlapping. On the right, we found that enterprises that are reporting less success or anticipated success with their efforts to make their networks ready for AI, those people that are, sort of like laggards, are are perceiving more risk from targeted attacks against their AI models. So it may be a situation where they're being challenged around protecting against that, and they feel like that is inhibiting their overall success, or their concerns about that kind of attack is making them conservative, and that conservative posture is leading to less success in sort of transforming the networks for AI. There are probably a few other things that you can think of personally that would be causing that correlation, but those are the two that come to my mind. So what are they doing to protect their AI investments from security risk? Number one, most of them are encrypting AI data. So at rest or in transit, they are encrypting that as much as possible to reduce the risk of compliance violations and data leakage. They also are using AI-powered security monitoring, which is not necessarily new. I mean, a lot of like NDR vendors have been leveraging machine learning for quite a few years, but it looks like this is more top of mind for them, that they want AI-powered NDR and other types of XDR and things like that to help them lock down their AI investments. And then most of them are also looking at AI-specific threat intelligence feeds and detection of threats and things like that. And then AI-driven security policy automation, like using AI tools to optimize how they design and manage and enforce policy around access and things like that. And then a little over half are adopting network security solutions that detect and prevent AI-specific attacks. So some kind of like firewall or IPS IDS solution or something like that that has some uh, deep visibility into AI-powered like a malicious activity that is leveraging like AI, like maybe picking up on signatures for that, or seeing patterns in network behavior that tell them there might be some kind of AI-powered attack going on. And then more than half are also implementing zero trust security for AI workloads, and a fewer number are applying zero trust security across the WAN. So AI, doing some sort of like zero trust segmentation in data center and the cloud around their AI workloads, and then also zero trust security across the WAN about what traffic's allowed to um, traverse the tunnels on their SD-WAN overlay or SASE overlay. All right, so all these changes we're seeing around network infrastructure, network security infrastructure, a key piece that I always try to think about in any type of transformation of networking or optimization of networks is like, how do you manage it on a day-to-day basis? Like, how do you empower your NOC and your network engineering team to proactively make sure that this network is successfully supporting AI? So only 47% of the people in the survey believe that their current network observability tool sets are completely ready to manage AI networks. Um, 68% said that they strongly believe that their tools should be leveraging AI to manage AI. AI-driven network management is a very hot topic now. It's driving a little bit of, well, a significant uh, consolidation, mergers and acquisition activity in the market. Most of the network infrastructure and network management vendors I talk to regularly are investing in AI to enhance their day zero through day two operations capabilities around their solutions. Uh, um, so these organizations generally believe that that should enhance their ability to manage AI and especially on network observability. Um, we asked them what kinds of data collection adjustments they need to make or have made to enhance their network observability solutions to support managing AI networks. Uh, More than 2/3 said real-time network metric monitoring. So they want more granular data. Instead of pulling their network every 5 minutes to get metrics from their infrastructure, they might be pushing harder to stream things using streaming network telemetry, get real-time data as it happens. Real-time flow monitoring. They want to collect flow data more granularly as well. Maybe this will require some upgrades to network infrastructure if it starts to tax the ASICs on their switches and routers to generate data more granularly. And then just broader coverage, collecting data from the end-to-end network as opposed to being more selective. They just feel like it's more critical for them to actively monitor and manage more of their network as opposed to strategic points on the network. Maybe there are just more strategic points on the network that need to actively monitor, especially when there's just a ton of east-west traffic happening in the data center, for instance. And then a third of them said they need to scale up their ability to capture packets for forensic analysis, for instance, for troubleshooting, for security investigations, things like that. We asked them what kinds of reporting and analysis adjustments you'd like to make to your tooling. And the number one response, nearly 60% said, I want AI application recognition and intelligence. So, for instance, I'm monitoring network traffic. I want to be able to see what, what traffic on my network is caused by AI workloads. I want to be able to see what kind of AI it is. Is it sanctioned AI? Is this like shadow AI that's gumming up my network and slowing down my corporately sanctioned AI traffic? Things like that will be really important, obviously, based on their responses. And then 46% say, well, I want predictive congestion analysis. I want to know where congestion is going to happen before it happens so I can proactively manage it and prevent it. And 42% said anomaly detection for AI related traffic patterns. So that can tell you, that can be supportive around like security monitoring, but also around optimizing the network, to detecting anomalies that might predict that an AI application is going to have problems or start failing, or is going to need more bandwidth in a certain location. Maybe you need to adjust the traffic for, to make sure that as anomalies emerge, that they are managed actively. And then 34% said, I want GPU cluster traffic pattern analysis. There's just a general interest in being able to sort of make your network observability tools more aware of, where the GPUs are in your data center and how those GPUs are going to impact, like what kind of patterns and traffic are caused by them as they are running AI workloads, and just being able to sort of be smarter about um, how compute, this super powered compute can really hit your network hard with unexpected traffic patterns. Because it's just, you can go from 0 to 1,000 miles an hour in no time when AI workloads just start generating a lot of traffic suddenly. So being able to analyze things from a GPU cluster perspective can really help you get smarter about how you manage and troubleshoot network issues related to them. So final thoughts, 67% of the people we surveyed believe that they will be completely successful with preparing their networks for AI eventually, even though less than half felt like their data center networks and their WAN networks were completely prepared for AI traffic today. Most of that optimism came from the 33% of people in the survey who were CIOs and CTOs. The rest of the people in the survey tended to be more moderate in their expectations for success. I'm talking about the technical personnel and the middle management people. So engineers, architects, project managers, managers, IT managers, IT supervisors, IT directors, they were all more likely than IT executives to say that they're anticipating less success. And I think you should listen to them and be prepared for what's holding you back. And then we saw some potential best practices based on how they're answering that anticipated success question. One, people who hired AI experts to enhance their AI center of excellence or their AI focused IT teams around were anticipating more success than people who reported that they're trying to train up existing personnel. So that tells me that you definitely want to train up your existing personnel because they are important resources that you want to ensure can contribute to your overall goals around preparing your networks for AI, preparing your entire IT infrastructure for AI. But you should be competing on the open market, in the labor market, for AI experts that are already out there today to accelerate and ensure more success. People who said that they were seeing a lot of traffic related, well, people who are seeing traffic and managing traffic associated with connectivity to third-party networks like large language model providers, for instance, those people who are really trying to optimize that were reporting more success. So you want to really think about connectivity to third parties. That's going to be a key piece of your AI networking strategy. Those people that were thinking about that were doing better. You want to automate AI traffic prioritization across networks, like quality of service. So you don't want to, adjust things as you see a need for prioritization. You want to prioritize AI traffic automatically as much as possible. WAN acceleration techniques, they were that the more successful people were looking at. They were really focused on AI aware data transmission acceleration and AI aware WAN remediation techniques. Those people that were focusing on that were doing better. And then people who said that they were leveraging edge compute to address WAN latency were also expecting more success. So with that, I'm going to turn it over to Raleigh for Q&A. But thanks for joining me today. And as you can see here, this is a link to report. It's in our research library, free to subscribers. Lots more data, lots more insights and analysis available in it. I think some, if not all, the sponsors also might have distribution rights to it. At least one. I can't remember off the top of my head, but anyway, this is the link you can get it from us. But with that, turn it over to Raleigh. Thank you.
Great. Thank you, Shamus. As Shamus mentioned, I'll be sending more information about the report in the follow-up email, so be sure to check that out. And you will also be able to listen to the on-demand playback as well. Shamus, getting into the questions, the first one is, what do you see as the role of the DPU within AI infrastructure? Vendors like CoreWeave and Checkpoint are pushing the narrative that the CPUs would benefit from the network traffic being offloaded to the DPU. Curious as to what your thoughts are.
Yeah, I mean, I think that's been discussed even before the AI hype cycle got rolling. DPU and SmartNICs as a way to offload network processing from CPUs or GPUs, I think is compelling. And obviously, these early adopters, many of them are looking at that to offload things like, you don't want, if you're, for instance, like one of the most popular steps people are taking to mitigate security risk around their AI investments is encrypting data. You don't want to have your GPU clusters decrypting that data on their, it'd be better to offload that to a DPU so that the AI workloads are not competing with resources to decrypt to decrypt that data. So it makes a lot of sense to leverage that for that, and things like load balancing closer to the server or having network security deployed closer to the server on the server and connected to the server, so that you're minimizing latency by not having to hairpin traffic back to layer 4 through 7 device, whether it's for networking or security purposes. It makes a lot of sense to leverage DPUs. I don't know if everyone's going to do it, but a lot of people in this survey said they're planning to do it.
Thanks, Seamus. For the WAN, what types of edge computing is being used? MEC, containers on routers? Any thoughts?
We did not ask them about that. We didn't dive that deep into the edge compute thing, so I don't really have any insights for you there. I haven't really talked to anyone one-on-one about that either. So yeah, I don't have an intelligent answer for you.
Okay, thanks. Let's move on to the next question then. Are these people using AI to improve how they manage networking for AI?
Well, I mentioned that 68% strongly believe that AI-driven network management tools would enhance their ability to manage AI networks. Another 31% said they somewhat believe it. So that tells you 99% of the 269 people we surveyed buy that argument that applying AI capabilities to network management will be good and help. We asked them about use cases around that, and there was the first thing that came up was predictive analytics. We want to prevent problems and proactively optimize the network for AI traffic before issues start making a mess of things. We believe AI has the ability to support our need for predictive analytics. And then many are also saying that they were specifically interested in AI co-pilots, these virtual assistants that you can use to query your network, organize work, push automated change was the second big use case. And the third one is intelligent traffic engineering, like maybe being smarter about how you route traffic across your network using like AI-based capabilities that maybe your SD-WAN vendors or your switching vendors are developing. So yeah, that's what we saw in the research.
And Seamus, are there any best practices for securing AI?
I think I mentioned more successful organizations we saw indications that they were better at addressing targeted attacks against the AI models. So they were organizing their defenses against that. Leading organizations also said that they're like people who were expecting more success told us that they were adopting AI-powered security monitoring tools. Like, so, as I mentioned, like AI has been behind the curtain of a lot of security monitoring tools for years, mostly in the form of machine learning, but they want more. They want more AI there. And then um, people who were encrypting as much data as they could associated with their AI traffic were also reporting more success.
Okay, thank you. Let's take one additional question. What kinds of traffic is being generated by training of AI models?
Okay. Just looking at the research. Yeah, so 2/3 reported they are seeing or expecting to see a surge in traffic between their data centers and the public cloud providers, which kind of lines up with the fact that like one of the biggest things they're doing on their WAN was adopting um, like low latency, high performance data center cloud interconnection services, or adopting those sort of cloud interconnect service providers that can provide those sort of like AI optimized connections between their data centers and the clouds. Most were also seeing more traffic out to the enterprise edge. We've been talking a lot about the edge here, and people are seeing or expecting to see a surge in traffic going out to their enterprise edge from both from their data centers and from their public cloud environments. They're connecting AI workloads in those sort of central locations to corporate data that's residing at their edge. And as I've already kind of alluded to multiple times, like we saw throughout this research that AI workloads were being deployed at the edge of their networks to mitigate any latency issues, congestion issues associated with that sort of explosion of traffic from the data center and the cloud out to the enterprise edge. So I think that, right now, lots of traffic happening. People are looking at distributing their workloads to sort of mitigate the challenges around having so much data at the edge of their network that AI workloads need to connect to. So right now, lots of traffic happening. In the future, maybe they can tamp that down by deploying a lot of workloads at the enterprise edge, but remains to be seen like how much of the workloads will go out to that edge.
Thanks, Shamus, for taking those questions. And I wanted to thank the audience for taking time out of your schedule to join us. As I mentioned, you will be receiving a follow-up email from EMA, so be on the lookout. And I hope we'll see you at a future EMA research webinar. Thanks again for joining us, and enjoy the rest of your day.